All right, so in this worksheet, you want to find the equation of a line, and somewhere in the directions it does say right here, you want to write your answer in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So meaning you want to get y by itself. And so in each of these problems, you're given the slope. So you notice the slope in each of those problems are given, and you're also given a point on that line. And so once you're given the slope and a point of that line, you can find the equation of a line. And in this case, remember you want the answer in slope-intercept form. Okay, so there are two ways or several ways to find the equation of a line using algebra. And the way that was in the lesson was this. So the first, let me go ahead and put this as number one. So remember, number one, you had the slope was 3, and it goes through this line, contains the point, or goes through the point, -4, 5. And so if you want to find the equation of a line that has this slope and contains this point, what we did in that lesson was we first of all used point-slope form. Point-slope form. And so point-slope form will help you to find the equation of a line. But if I'm going to use point-slope form, I need to know a point on the line, which I do, and I need to know the slope of the line, which I do. So that's why in these problems, it's easier to use point-slope form, because in each of those problems, you're given a point and the slope of that line. Now remember, a point-slope form is this. Y minus y1 equals the slope times x minus x1. That is point-slope form. And when using, I'm going to go ahead and write the point here. So the point is -4, 5. All right, so remember, in order to use this, in order to use point-slope form, you're going to have to substitute the point into this equation and the slope into this equation. Now, when substituting the point, see, this is the point here. When substituting the coordinates into this equation, this is going to be substituted for x1. So -4 will be substituted for x1. And then 5 will be substituted for y1. All right, so it's always a good idea to label x1, y1. All right, so now we're going to substitute. So I get y minus y1, my y coordinate of the point. So that's going to be the y coordinate of the point, which is 5, equals the slope, which is 3, times x minus x1, and the x coordinate of my point is -4. Before you do anything else, always look at this expression that's inside the parentheses. We all know that x subtract -4, you can always change subtraction to addition, and that's what you want to do here. So x subtract -4 means x plus. So remember, when changing subtraction to addition, always take the opposite of that number following the subtraction sign. So x subtract -4 means x plus the opposite of -4, which is a +4. So x subtract -4 is equivalent to x plus 4. So that's what you're going to write here. So I get y minus 5 equals 3 times x plus 4. All right, now remember the direction said write your answer in slope-intercept form. So now we've got to get y by itself. So I've got to get that variable y by itself. But before I do that, let's go ahead now and get rid of the parentheses. So I'm going to go ahead and use the distributive property. So you get y minus 5 equals 3 times x is 3x. 3 times a +4 is a +12. So I get this expression here is equivalent to 3x plus 12. And then to get y by itself, right now I'm subtracting 5, so the opposite would be to add 5. And notice I'm aligning my like terms. So I'm adding 5 to both sides. What I do to one side, I do to the other. And I'm aligning my like terms, so it makes it easy for me to combine. So now I'm going to combine my like terms. 5 and a -5 is 0. So I get, remember that 0 right here. So 5 plus 0, y plus 0 is still y, equal. And then 3x, and then +12 and a +5 is a +17. And there's your answer. All right, so that is the equation. This right here is the equation of the line that has this slope and contains this point. And so there's your equation. So just to let you know, though, and remember, this is slope-intercept form. That's what you wanted. So So just verify that, remember when you have slope-intercept form, the coefficient of x is your slope, right? So verify that this number here, 3, is the same as this number here, 3. All right, now, you can also check yourself, just to let you know, you can check, and I'm going to go ahead and use this. So you can check to see if this equation is true. So let's just check y equal 3x plus 17. So let's see if that's true, if this is correct. So to do that, you're going to substitute, see this point here? You're going to substitute negative 4 for x and 5 for y, because this is the equation of that line. So the equation of that line must contain that point, right? So if I substitute these values of x and y into this equation, the left side better equal the right side. So let's go ahead and do that. So I get y is 5 equal 3 times x, which is negative 4, plus 17. Well, 3 times negative 4 is a negative 12, and negative 12 plus 17 is indeed 5. All right, so all this work is correct. So it's very easy. It's very easy to check to see if this is, through all this work, if this is correct. You just go back, take this number, this point, in place of x, substitute negative 4 in this case. In place of y, substitute 5, and verify that both sides are equal. All right, and you notice that 5 equals 5. All right, let's look at number 2. And remember that this is your answer. So this is your work. This is the work right here. And then this is your answer in slope-intercept form. All right, number 2. So number 2, we had this time the slope is negative 3/4, and it contains the point, the line contains the point 8, negative 3. So the slope is negative 3/4, and the point is 8, negative 3. Now remember, we want to find the equation of a line that contains this point and this slope. So it's very easy to use point-slope form again. So remember, point-slope form is y minus y1 equals the slope times x minus x1. And so in place of slope, in place of m, you're going to substitute negative 3/4, and in place of x1 and y1, you're going to substitute the coordinates here. So this is x1, this is y1. So I get y minus y1, which is a negative 3, equals the slope, which is negative 3/4, times x subtract x1, which is a positive 8. All right, so you see this y subtract negative 1, just like this one. X subtract negative 4 is equivalent to x plus 4. You want to do that here first. So you want to rewrite y subtract negative 3 as y plus 3. So adding the opposite. Changing subtraction to addition. So the opposite of negative 3 is a positive 3. Equal, and I'm going to go ahead and just rewrite this over. All right, so the first thing I did to go from here to here, I just went ahead and I changed the subtraction to addition, because that was and some students say, I see this double negative. So subtract the negative means adding the positive. All right, so now we're going to go ahead and use the distributive property to get rid of the parentheses. So I get y plus 3 equals negative 3/4 times x is a negative 3/4 x. Now remember, a negative times a negative is a positive, right? Okay, so now what we're going to do is, now we've got to multiply 3/4 by 8. So let's look at that. 3/4 times 8, right? Okay, so let's reduce this. 4 into 4 is 1, 4 into 8 is 2, and then 3 times 2 is 6. So a negative 3/4 times a negative 8 is a positive 6. All right, and then to get y by itself, because you want your answer in slope-intercept form, so we can get y by itself. Right now I'm adding 3. The opposite is to subtract 3. And notice I'm aligning my like terms. And I'm going to combine like terms. 3 and a negative 3 is 0. Y and 0 is y, equal negative 3/4 x. 6 and a negative 3 is a positive 3. All right. Now, so there's your answer. Assuming all this work is correct, then this is the equation in slope-intercept form. But remember, for worksheets, you have time to quickly go back and check and see if this is correct. So I have y equal negative 3/4 x plus 3, right? And remember, my point remember is 8, negative 3. So first of all, verify that the coefficient of x, once you get y by itself, verify the coefficient of x is indeed the slope, and it is. And then let's just quickly check and see if this equation is correct, because this point that it contains would have to be on this line here. So the left side would have to equal the right side. So y is -3, and then we want to see if that's going to equal -3/4 times x, which is 8, plus 3, right? Okay, let's remember. So you have to simplify the right-hand side. The left-hand side, there's nothing you can do there. It's just -3. But remember, order of operations. So I have to multiply before I add. So let's go ahead and multiply. 4 into 4 is 1. 4 into 8 is 2. A -3 times 2 is a -6. And -6 plus 3 is a -3. And that's what this was right here. All right. So what I have is correct. Okay, now let's look at number 3. So number 3, I have the slope for number 3. The slope is -5, and it contains the point -1, -4. All right, so if you want to find the equation of a line that contains a point and a slope, then we're just going to use the point slope form. Y minus y1 equals the slope times x minus x1. That's easy to use. But we got to substitute now. So my slope is -5. So in place of m, I'm going to substitute -5. And in place of the x1, y1, I'm going to substitute these coordinates. So this is x1, this is y1. So in place of x1, I'll substitute -1. And in place of y1, I'll substitute -4. So I get y subtract y1, which is a -4, equal the slope, which is -5, times x subtract -1, x1. So there's that double negative. So let's go ahead and simplify this. Y subtract -4 is equivalent to y plus 4 equals -5 times. X subtract -1 is equivalent to x plus 1. All right, and then finally we need to get y by itself so we can put it in slope-intercept form. But before we do that, let's go ahead and distribute. Get rid of the parentheses. To get y plus 4 equal -5 times x is a -5x. A -5 times 1 is a -5. Getting y by itself, right now I'm adding 4. The opposite is to subtract 4, so notice I'm aligning my like terms. And so a -4 and a +4 is 0. Y and 0 is y, equal -5x. A -5 and a -4 is a -9. And so there's your equation in slope-intercept form. So that's a slope-intercept form. So there's the work, and there's your equation in slope-intercept form. Verify that when you get in slope-intercept form, verify that the coefficient of x is indeed the slope, and it is. So just like we did in the previous problem, if you want to, you can check to see if this is correct. So my equation of that line is y equals -5x minus 9, right? So that means that this point here, this point better be on that line, the point -4, -1. So in place of x, I'll substitute -1 rather, and in place of y, I'll substitute -4. So I get -4, and we'll see if that's going to equal -5 times x, which is a -1, subtract 9. Order of operations, I'm going to have to multiply before I subtract. A -5 and a negative times a -1 is a +5, and 5 subtract 9, remember, means 5 plus a -9, and 5 plus a -9 is a -4, and that's what this is. So there's my answer for number 3. And then number 4, I have the slope is 5, 6, and the point is -18.5. So if you know the point and the slope of that line, then you can easily use point-slope form to help you find the equation of the line. So y minus y1 equals the slope times x minus x1. But remember, you have to substitute -18 and 5 into x1, y1. So that's the x-coordinate of my point, and this is the y-coordinate of my point. So I get y minus y1, which is 5, equals the slope, which is 5, 6, times x subtract x1, which is a -18. All right, but remember the double negative, x subtract -18, so I get y minus 5 equals 5, 6. So let's rewrite this. X subtract negative 18 means x plus the opposite of a negative 18, which is positive 18. So that's x plus 18. Now let's go ahead and distribute. I get y minus 5 equals 5, 6x. 5, 6 times x is 5, 6. And then I have 5, 6 times 18, right? So 5, 6 times 18. So let's go ahead and reduce first before we multiply. 6 into 6 is 1. 6 into 18 is 3. 5 times 3 is 15. So this right here becomes plus 15. And then finally, I got to get y by itself, so I'm going to add 5 to both sides this time. And then combining like terms, 5 and negative 5 is 0. And then I get y equal 5, 6x plus, and then 15 and 5 is 20. And so assuming all this work is correct, then this should be the equation of the line in slope-intercept form. Slope-intercept form. But again, you can check, right? You can always check these. So let's just quickly check. We do have time. So you have y equals 5, 6x plus 20. So I want to see if this point right here is on this equation, or satisfies this equation. So negative 18, 5. So in place of x, I'll substitute negative 18. In place of y, I will substitute 5. So remember, I found the equation of that line that contains this point and this slope. So the slope is correct, 5, 6. I just got to verify that this point is actually on this line. So if you have time, it's a good idea to check this. So y is 5 equal 5, 6 times x, which is negative 18, plus 20. So we have to multiply before we add. So 6 into 6 is 1. 6 into negative 18 is a negative 3. 5 times a negative 3 is a negative 15. And a negative 15 plus 20 is going to equal 5. And so that's the right-hand side's 5 and the left-hand side's 5. And there's your answer. So that is the key to the worksheet so that's the key to the worksheet on writing equations of lines given a point and the slope.